John, thanks for making time to talk to me this morning about your work. You were at Rolls Royce for 43 years as an engineer, and you designed, as I understand it, the world's lightest, most powerful engine, and that record has not yet been beaten. That's an impressive thing to have done, it seems to me. So you were there for 43 years, and the last 12 years of that time, from 87 to 99, you were involved in promoting the interests of UK industry around the world. In the days when people purchasing UK technology wanted to be convinced it would work before they purchased it. It seems to me to be a very important role. Maybe the world's moved away from that. But let's not have a conversation about that now. Let's turn to your views about the future of aviation. As you know, I've been arguing for a long time that the problem is not aviation, the problem is the fuel that they use, and it's about the carbon which gets emitted into the atmosphere. Do you think aviation has a good future?
Aviation is vital to the future of a harmonious population living on planet Earth. We do need to be able to meet each other face to face, bring our families together, understand our cultural differences, what motivates people in different countries and so on, and try and bring people to a common understanding. We have the technology to instantaneous language translation. You know, I can speak to an Indonesian in English, and the Indonesian will understand it and receive it in the Indonesian language, for example. And we have the means of instantaneous communication. So we can get our messages across using technology, but the level of trust people have between buyer and seller partnerships and all that sort of thing is very much one: do I trust you? Are you trusted by your company? Are you trusted by your government? Are your bankers in support? All these sort of things are very much to do with the person-to-person relationships, in embracing also the spouse, the children, even the grandchildren, so that there is an ongoing coalescence of mutual understanding underlined with mutual trust in doing deals which are pretty consequential for many, many people. And of course, we all share one climate, so many of the things we need to do will be the same, and indeed need to be the same across a very large proportion, if not all countries. You know, for example, if we're going to fly airplanes, we certainly need to be able to pick up a fuel in Russia that will work quite satisfactorily in America, in the UK, in Africa, and all that sort of stuff.
So clearly, John, you share my passion for making sure that travel and tourism can survive the crisis over aviation fuel. But are we moving in the right direction now? Are we going to get to aviation fuels which don't pollute the atmosphere?
Well, we certainly are, but the critical issue is we need to go much faster. So we really have got to take some quite difficult technical actions and roll it out across the world in really the next 10 years. That's really all the time we've got, because beyond that time, people are going to really be protesting that they're having a surfeit of floods, interruptions of harvest and so on by droughts, pestilence, as in locusts and all those sort of things. Now, from very early days, I think many people recognize that hydrogen is a near perfect fuel. It has a very high energy density, almost 3 times that of jet fuel, but it has a bunch of problems. But the other advantage is, well, there are a number. Secondly, it burns cleanly, or you can use it in a fuel cell where there's no combustion taking place. But probably for many applications, we still use combustion engines, but we will do so. Well, sorry about
Carry on, John.
my wife's got it. So we recognize that hydrogen's a very good fuel. The other thing is that so many industries, those who want to use renewables, those who want to use nuclear, really, in order to be able to match demand to supply, have got to use stored energy. Now, if that stored energy isn't used properly, and that stored energy can often be sold at a very low price. So we are looking at a prospect that the energy content of hydrogen is going to be greater per pound note or per dollar than any other fuel. So that's another reason for doing it. And I think in terms of things like contrails, we're going to be able to find that together with some techniques of cloud avoidance at high altitude, we're going to be able to also reduce contrails by going with hydrogen. But from the airplane point of view, the initial work was concentrating on how do we deal with this gas, which has high energy per unit weight, but if you don't squeeze it down to the point where it's a liquid, the volume is prohibitive. You could fly a journey across the road, but in terms of going from London to Africa to Australia and so on, that simply isn't on. It has to be liquid hydrogen. And liquid hydrogen is still not very dense. But what has become clear very recently is that if you take an airplane that is designed to run on jet fuel and fly for like 19 hours between London and Perth, non-stop, then the fuel tankage is sufficient in volume and in weight carrying capacity to carry all the hydrogen you need for a much shorter flight. And recent studies have shown that the travel industry is likely to move most quickly to short ranges below about 4,000 kilometers rather than this extreme long range. And here we now have an exciting opportunity in that if we're going to do those short range flights, if we try to do it with narrow bodies like the A320 and the 737, which are real workhorses of the travel industry, if we're going to do it with those, then we'll overcrowd the airspace close to the airports.
Right.
So we've got to reduce the number of movements. So this means that we need to carry more people per flight. And we just so happen to have an airplane which step by step, we can see how we can transform that into an airplane that flies with zero emissions and is able to do that longer range and to do it ultimately, perhaps within a decade, with a fuel that costs less per unit energy. So that means that there will be a strong pull on travel by air because it is so clean, which is not what people really think.
So now, the problem, John, is now essentially an engineering problem.
Yes, it
theoretically entirely possible. It's now all about the practical engineering to actually make it work.
Yes, I mean, there are so many things in life that are potentially life-threatening devices or fuels and so on. But so far, for the ones in use, we've learned to manage them safely. We carry, typically on a long-range airplane, 120 tons of jet fuel. Well, doesn't need much of a spark for that to go up, but we control it safely so that it pretty well never happens. We don't feel insecure in flying with the jet fuel. Correspondingly, we've got to learn how to be safe with hydrogen. And it is difficult, but there are no laws of nature which say you can't do it.
Right.
And because its value is so high in terms of getting people traveling around, which is the center of our human relationships, which is so important to the harmony across the world and to taking care of our climate, then we have got to be able to fly, and we must do it with zero emissions. Now, I can illustrate where the advantages come from, but I can't take you through all the details of how we take the world's most available element, which is hydrogen, but it's in gaseous form and very active. So it joins with carbon to make methane. It joins with lots of other carbons and hydrogen to make petrol, diesel, and all that sort of thing. But it's the carbon that's the bad news, because it produces, first of all, it produces carbon dioxide, which is a nasty greenhouse gas. It produces particulates that enable us to form contrails, which is another bad news in terms of global warming. Yep. And moreover, it's jolly heavy stuff to be carting around. So the first thing we can say is, although we might be talking about new build aircraft, let's think about an aeroplane that we've already got that can carry the hydrogen fuel for 4,000 nautical miles. Now, an A350-900 long-range aircraft can fly something like approaching 18,000 kilometers. But we only want to fly 4,000. So we can divide the fuel load of 120 tons down to around about 30 tons.
Right.
But roughly speaking, the energy value of hydrogen per kilogram or per pound weight is 3 times. Actually, it's 2.8, but keep it simple. 3 tons. So 3 times. So divide the 30 by 3 and you get 10 tons. So in other words, if we didn't have any penalties for carrying the hydrogen, then our airplane would no longer weigh 300 tons at takeoff. It would weigh just short of 200 tons. Ooh. So less drag, smaller engines, less induced drag because we carry less, lower takeoff speed, so lower noise after we cross the fence out of the airport, steeper climb to altitude. So we get many, many advantages. And if that is then combined, because everyone wants to move to liquid hydrogen as their fuel, the truckers, even the people providing electricity, I'm going to say on a grid, but I probably mean off grid, but with a distribution system for a local community.
Yeah.
Then we're starting now to talk about less fuel and less cost. So it really means that aviation has the prospect of increasing travel affordably and providing the people who are going to be flying as passengers are also involved in making all of the things that support the infrastructure, the airplane itself, the hotels and all the support structure that you have. Then we will be able to service the new capacity with the passengers that want to use it.
So John, just to summarize what you're saying, you're basically saying that in your view, we can see an expansion of the travel and tourism industry when we make the shift to hydrogen.
Yes.
The hydrogen is a liberator for people to be able to travel and to mix more internationally.
Yes.
That's a very optimistic assessment of the future.
Well, it is, but first of all, the laws of nature say you can do it. Secondly, when you make comparisons with the set piece direction at the moment of using a sustainable aviation fuel, then you're still carrying a heavy weight. You've still got to find the source, the consistent source of something the engines can burn safely wherever they pick it up around the world. And no doubt we can overcome those problems, but the real prize is going to hydrogen. If it were only aviation, the case would be weakened, but the truckers have to do it, because for them to survive and for us to survive with food brought in from afar and other goods and services, they must be able to match the productivity of the diesel engine, but we cannot. Nature will not allow us to do that if we can't get very close to zero emissions, and liquid hydrogen is the means by which that will be done. We can't have our renewables unless we have energy storage, and that energy storage has to be transportable to a new market like fuel cell powered motor cars, fuel cell powered aircraft that will do many of the roles now carried out by trains, taxis, buses on the surface, but which require an awful expenditure and a lot of work laying down safe pathways for the surface-bound traffic to use.
So, John, you seem to be arguing, I think you are arguing, that we can quite quickly potentially move to under 4,000 kilometers, which is most of aviation, in fact, fueled by hydrogen, and that the longer haul option is there as well.
The longer haul is certainly there, but it's a bit more distant, because it does mean that we're now only really getting the advantage of the energy content of the fuel. We're not getting the bigger weight saving that comes with reducing the range. So it means we have to move to what is commonly known as a blended wing body. Many people, I think, will have seen pictures of Maverick from Airbus flying as models. Many people will have seen the publicity information from Airbus, who are very forward thinking in these matters. Yeah. And are good people really to go forward with. But at the moment, they do need some persuading. You know, in talking with the seniors, I do find there's still a commitment to the, what I call the soft option of going for sustainable aviation fuel, which doesn't give you all the benefits that the world really needs, because we really have got to increase our social and our mutual trust coherence across the globe. And we're not going to do that entirely by technology, but my goodness me, technology makes it possible to reach many more people. So yeah, if it's data flow, money flow, easy. But mutual trust, that's all about, do I know you, do I trust you, and so on.
John, can I just push you a bit on what you think about SAF? Because sustainable aviation fuels, just today, the UK government has come out saying that they have this stretch target of 10% sustainable aviation fuel by 2035. That's 10% of the kerosene going into a jet by 2035 will be sustainable aviation fuel. There's only three sources, as I understand it, of sustainable aviation fuel. One is food waste, but we know that there are big efforts to reduce food waste. So if there is a supply, it's being reduced. The other is any kind of biofuel. But then there's a real problem about competition with food.
Yeah.
But then the third SAP, and this is where I think people are being disingenuous by mixing these three together, is actually power to liquid fuels made using hydrogen. And yet we talk about them all as SAP. They're very, very different, aren't they, in terms of the carbon?
They are indeed. Well, I mean, you don't have to be too smart to realize that in emission terms, a 10% of ethanol or something like that in the fuel is going to lower the calorific value a bit. So it'll have a range penalty. You're still burning an awful lot of kerosene. So there's an awful lot of CO2, NOx, particulates, and we'll still be forming the contrails, and those will still be merging with the cirrus clouds at high altitude. So in terms of what it does for greenhouse gas, it really is a very weak tool. Now, there are people who, and I think United are already flying with 100%, but nonetheless, you've got the issues that you've spoken about. Where does that sustainable fuel come from? And really, we know what's best. Why don't we get after it? And why don't we do it properly and thoroughly and now? Unless anybody can find a reason why you cannot, and as I understand the rules of nature, cannot is not a word that applies here. You can. It's
Now,
not
one of the things which I've always wanted to ask somebody, and I think you might be the first person I risk asking this question on, but if I think about food waste and biofuels, those two forms of SAF, it seems to me that really it's a sophisticated reuse, because you've taken something which, if it was allowed simply to decay, would push out greenhouse gases.
Yes.
And what you're doing is reusing it, but you're still pushing out the greenhouse gases. You're not actually you are still pushing out greenhouse gases by burning SAF.
Well, you first of all, you're hurt by not saving the waste fuel and turning it into something that is consumed or makes energy. But really, that's the number one thing. We all know we need to cut down that waste. Secondly, you've got to use energy in order to carry out these processes that make it into sustainable aviation fuel. Moreover, you've got to do it consistently from whatever the source is all over the world, because airplanes can get you just about anywhere.
So, John, just to kind of come to a conclusion, I'm feeling optimistic because of what you said. And it seems to me that the travel and tourism industry that I work with should also be optimistic, because what you're saying is if they change the fuel, there is no reason why we can't continue to grow the sector. Yes. And that would obviously be good for humanity, in my view. I think you and I share that perspective. Where do you think the real engines of change for this are going to come from?
I actually feel that it's going to be the likes of the independent carriers, the EasyJet and people in that category and their position in the market. Just as in the Industrial Revolution, it wasn't government that brought about the change. It was a few smart entrepreneurial chaps who had enough credibility to arrange for finance to employ people. And because that gave rise to automation, there was a fairly fast payback time. That meant that goods were affordable. So the market grew because they were affordable. And the market also grew because in mass production, the consistency was there. So every good one worked and there were no bad ones. Slightly exaggerated to make a point, but it was that sort of a process. So what we've got to do is to make sure we do it very thoroughly. We've got to have fallback positions for when lack of understanding bites. But, we've been there many times before. I personally have been there many times before. well, hopefully not too many, but we've always had a plan as to how to recover. And it's crucial that, first of all, we get the pressure from the independent airlines in particular, and the travel industry to say, look, you know, a travel industry has an important role in getting people to sing from the same hymn sheet, to understand each other and to trust each other. We can do much of it online, but we have to get to the position where we trust each other and we know that we are trusted by the people we deal with in our own country.
One of the things that strikes me, John, is that you've several times in these two interviews talked about the importance of trust. And that's really at the heart of the whole idea of responsible tourism. There's a very nice connection there between them.
Yes.
And obviously the COVID pandemic has caused people to refocus on responsibility and trust in terms of reassuring people that it is safe to travel. But I really wanted to end by saying to you, it seems to me that we're on the cusp of a major change, of shifting from the rather sterile debates about whether climate change was happening. There are very, very few people now who don't recognize that climate change is happening. There are still a lot of people who think there are easy, cheap fixes, particularly around SAF. And there's confusion about what we mean by SAF. And I think it's important that you and I have just discussed that.
Yes.
But the reality is that if Airbus, EasyJet, and the others working together are able to make the change, then the travel and tourism industry can grow again, not only for the benefit of, as you've said, of people having the opportunity to travel and to learn to trust others, which goodness knows we need for the future of humanity, but also for those countries which are desperately dependent on tourism and without aviation will lack the ability to earn foreign exchange and to survive in the modern world.
Well, I think, Harold, there is yet another reason, and that is we need people to travel to where the advances are being made. I mean, I would love everyone to go to Shanghai, to go in a hotel and to order a meal from a restaurant outside and see it delivered to the hotel lobby. It then goes into a robot that says, I'm a hot meal, get out of my way. It makes its way across the lobby, pushes its way to the front of the lift, pushes the button, knows it's got to go to 431 to room so-and-so, and it navigates its way up there with great speed, knocks on the door and says, sir, madam, your meal has arrived. I'll be back to collect the empties when you let me know that that is the case.
Extraordinary. There really is a bright future for travel and tourism, John, if we can just make that transition.
Yes.
I'm going to, with this video, John, I will put out a section of your book, I hope, and encourage people to buy it. But I think for me, today's been quite uplifting, realizing that if we just focus now on the engineering, and if people commit to that and stop debating whether climate change is happening, we can make the kind of progress that assures that travel and tourism will have a very prosperous and growth-orientated future, which is what we need for humanity. Thank you very much indeed, John.
You're most welcome, Harold.